So let's understand the topic of electrical current with a different perspective. That is in terms of power, energy, and work. So the very definition of power is rate of doing work. So if we make use of that, we can derive a formula of power in terms of current, voltage, and resistance. So let's begin with P is equal to W by T. That's what rate of doing work means. Now we know that W is equal to V into Q. Do you remember this? Volts for P, is it not? So let me write it over here. If I substitute this in our formula, we have P is equal to V into Q by T. But we know that Q by T is your I. So we have P is equal to V into I. So the best way to remember this is, please vote for India. That's it. So this is your formula. Now, what is the SI unit of power? Watt. WATT. So whatever the traditional unit of power is, the same holds here as well. So it's named after a person, so we have to write it in capital letters. If not, if you're spelling it out, small letter W and the rest of it. So like anything else, we need to define power in terms of voltage and current. We've been doing that, so we have to continue to do that. So we have 1 watt if 1 volt, and we have 1 ampere. So I mean 1 into 1 is 1. That's what I'm trying to show. So, but how do you put it across as definition? Well, I have the definition over here. It is a power consumed by a device that carries a 1 ampere of current when operating at a potential difference of 1 volt. Right? So we talk in terms of power consumption, because power consumption is what, when you talk about refrigerator or heater, it consumes a lot of power. So this is the basic idea. It is a power consumed by a device that carries 1 ampere of current when operating at a potential difference of 1 volt. The traditional definition is that the watt is said to have power of 1 watt if it does work of 1 joule in 1 second. So this is just for your knowledge sake, but this is what you guys have to concentrate on. Okay, so I'll show all of that. Let me come back to this. See, there are a few more expression of power that we need to know. Actually, it's quite simple. So from Ohm's law, we have V is equal to I into R. If we happen to substitute that over here, so we have P is equal to I into R into I, which is nothing but I square R. Then also we have P is equal to, if in terms of I, it will be V by R. So V into V by R, which is V square by R. Again, it need not by heart this because it doesn't make sense. But yeah, it's there, and it's just to show you guys that it's there. That's it. Okay, please don't by heart all of this. It doesn't make sense. You can derive it. It's quite simple. Or if you want to memorize this, you can do it so with the help of this. And whenever you require, you can substitute V is equal to I into R or I is equal to V by R and derive this too. Okay. So power is the rate of doing work. And we end up with P is equal to V into I. SI unit of power continues to be watt. And we need to define 1 watt. So 1 watt is equal to 1 volt into 1 ampere. But yes, putting it in terms of a sentence, it is the power consumed by a device that carries 1 ampere of current when operating at a potential difference of 1 volt. Quite simple. Okay, so please pause and you need to copy all of it. Other than this, not required.